Let us now proceed to function notation and evaluating functions. So in the previous lesson, we discussed how we actually distinguish or differentiate function from mere relation. This time, we will focus more on the concept of function and how it is applied in real life. So function notation is defined as a functional notation f of x means the value of the function at number x. So you can use f of x, g of x, or c of x. This is the helpful way to distinguish equations of functions when you are dealing with more than one at a time. So we have here three examples. F of x equals 2x plus 1, g of x equals 7x minus 10, and c of x equals 5x plus 10 all over 3. So take note that in naming your function, you may use any letter, whether that is capital or not. Let us now proceed to this function machine. So our function machine will have an input, the function, and output. So input is your x, output is your f of x, or this is also referred to the y in our equation. So input and output. Input is the one that you put in a function, output is the result. Independent variable or input, the value of x and does not depend on anything. This is the cost in your function. Dependent variable or output, the value of f of x, and depends on what the input is. This is the effect. So whatever is the outcome of the output, this is completely reliant to what we just simply put in this function. Okay, example, determine the effect of soda on blood sugar levels. So independent here is the amount of soda, and the dependent variable is the blood sugar level. So your input again is the cost, and the output is your result. So the things that you can change is the input. This is the one that you change a lot. The output is simply controlled by whatever you place in your input. Let us now proceed to evaluating functions. Given. So we have this as our function. You read this function like this. Given f of x equals 2x plus 1, find f of 5. So while the notation and wording is different, the process of evaluating a function is the same as evaluating an equation. In both cases, you substitute 5 for x, multiply it by 2, and add 1, simplifying to get 11. In both of a function in an equation, an input of 5 results in an output of 11. So we have this process, f of x equals 2x plus 1. You substitute x by 5. So you have f of 5 equals 2 times 5 plus 1. Evaluating 2 and 5, you will get 10. Then you add 1, and it will result to 11. Therefore, f of 5 is 11. Let me just discuss to you now how to apply this concept in an equation.
Okay, so we're going to relate now the evaluating of function to the evaluating of equation. So as you can see, we have here f of x equals 2x plus 1. So we will be rewriting this as an equation. So instead of writing f of x, I will write y. But I will just simply copy the 2x plus 1. Alright, so let us now replace x here by 5. So we let x be equal to 5. So substitute x by 5, you still have 2 times 5 plus 1. So 2 times 5 is 10. You add 1 and you will have a result of 11. So this one here is evaluating equation, here is evaluating functions. But the process and the answer are just the same.
Try on direction. Given the functions below, evaluate the following. Number 1, we have f of x equals 10x minus 5. You have to evaluate f of 3 and f of negative 4.
Okay, let us now evaluate f of 3 given the function f of x equals 10x minus 5. So we'll just simply substitute here the x with this value, which is now 3. So 10 times a 3 minus 5. So 10 times a 3 is 30. Then you subtract 5, you will get an answer of 25. So our final answer for f of 3 is 25. Let us now do the same process for f of negative 4. So I will again copy this function here, but instead of writing x, I will replace it by negative 4. Then we subtract 5. So this is negative 4 times 10, or 10 times negative 4 rather. Negative 40, you subtract 5. So this is like adding two negative numbers, so your final answer must be negative 45. So we write our final answer as f of negative 4 equals negative 45.
Second example, we have g of x equals x over 2. Evaluate g of 6 and g of negative 1.
Let us now evaluate this g of x equals x over 2. So let us now find g of 6. So as what we did in the previous process, we will just simply copy our function here, but instead of writing x, we will replace this by this value. So 6 divided by 2 is 3. So our g of 6 is positive 3. So we'll again do this for g of negative 1. So I will copy this function again. So instead of writing x, I will replace it by negative 1 and copy 2 in our denominator. So this is the final answer. You may also rewrite this as negative 0.5. If you want to write your answer in fraction form, make sure to move this sign here, the negative sign, aligned with your fraction bar.
Number 3, h of x equals x squared plus 7. Evaluate h of negative 5 and h of positive 4.
Okay, for this third example, we have h of x, which is equal to x squared plus 7. Evaluate h of negative 5. So again, we will follow this function, but instead of writing x, we'll replace it by negative 5. We square the negative 5, then we add 7. Okay, and after that, square negative 5 is 25 plus 7. You will get an answer of 32. So the final answer for h of negative 5 is 32. Let us now evaluate h of 4. So we will be doing the same process. So we square this x, which is now 4, plus 7. So this is now 16 plus 7. Adding 16 and 7, you will get 23. So h of positive 4 is 23. Okay, so our function is a of x equals 3x squared. Find a of negative 2, a of negative 1, a of 0, a of 1, and a of 2. So first, I will be creating here a table, and later on, we'll compute the different values. So here is the x column, and here, instead of writing y, we can write here our function a of x. Right? So you may also refer this to your y, or this is our output. So we'll just simply copy all x values. So where can we find our x value? So these can be found inside of the parentheses. So we'll have negative 2 to negative 1, 0, 1, and 2. Okay? We'll compute now for the values of this. So as for our solution, we have a of negative 2. We'll copy this function. So this is like 3x squared, but we will replace the x by negative 2. So this is like 3. Squaring negative 2 is positive 4. So 3 times 4 is 12, and we now have a of negative 2 is positive 12. So we will repeat this process 5 times. So because we have here 5 different cells. So a of negative 1 is 3 times the square of negative 1. So you'll have 3 times 1. This is 1. And you now have a final answer of 3. So a of negative 1 is 3. So we repeat the process, a of 0. So this is like 3 times the square of 0. So you have 3 times 0. Your final answer is 0. For the fourth solution, we have a of 1. So it is like 3 times the square of 1. So 3 times 1 is simply 3. So a of 1 is 3. And the last computation is a of 2. So we have 3 times the square of 2. We have 3. This is 4. When we square it 2, this is 4. And we now have an answer of 12. So our output, we have to collect this output and put this on the second column of our table. So this is a 3, this is 0, this is a 3, and this is 1. We're going to create now our graph. So we will remove the solution and create a graphical presentation. So creating now a graphical presentation, of course, you have to use these different values here. So we're just going to create our vertical axis. So this is your y, or this is also your a of x. Okay, and we'll have here, this is our x. So for the x values, we have here from negative 2 to positive 2. So I will use an interval of 1. And for the y-axis, we have a maximum of 12 and a minimum of 0. No negative values for y. So I will be creating here my interval. So I will be dividing this into 4 lines. So this will be 12, 9, 6, and 3. Okay, plotting now the given point. So we will going to have here coordinates like negative 2, positive 12. Here is negative 1, positive 3, 0, 0, 1, 3, and 2, 12. So we will now plot. We have negative 2, positive 12. So our first point is located here. The negative 1, positive 3, 0, 0, 1, 3, and 2, 12. Connecting now the points, we have to create a smooth curve. And we now have a graph. To make our graph complete, we can also label our coordinates. So we'll have here 2, 12, 1, 3, 0, 0, negative 1, 3, and negative 2, 12. Okay, using the function b of x equals 15x plus 21, we will complete this table, and later on we're going to create a graphical presentation. So the first one, we're going to have here the b of 2. Okay, b of 2 because our x value is 2. So I will copy this 15x plus 21, but I will be replacing this x by 2. Okay, so this is like 15 times 2 plus 21. 15 times 2 is a 30 plus 21. You will get a total of 51. So b of 2 is 51. Okay, next would be b of 4. Okay, so this is our first solution. Second solution, b of 4, so it is like 15 times 4 plus 21. 15 times 4 is 60. Plus 21, you will get a total of 81. So b of 4 is 81. Third solution, we have b of 6. So b of 6 is like 15 times 6 plus 21. So 15 times 6 is 90 plus 21. That will give us 111. So our b of 6 is 111. And the last one, b of 8. We have here 15 times 8 plus 21. 15 times 8 is 120. Plus 21, you will have a total of 141. So this is our b of 8. So right after we've completed this computation, we will now write our answer on our table. Okay, and after that, we will create our graphical presentation. We have to be careful with our scaling because Once our scale or our interval is incorrect, our graphical presentation will also be incorrect. So I will be making use of the first quadrant since I don't have negative numbers here. So this is my y, or this is also my b of x. Here will be my x. So x, I will use an interval of 2. So 2, 4, 6, 8. And for my y, I will be using the interval of maybe 30. Okay? So it's okay if this is not really reflected on our labels. Okay, after that, I will plot my coordinates. So I will have first the 251. So 2 for x, 51 for y. So roughly it is located here. We'll just estimate the location. So 251. The next is 481. So roughly on this area also. Okay, so 481. 6 would be paired with 111. So this is roughly on this area. 6, 1, 1, 1. And for 8, we have 141. So roughly again on this area. So we'll just do the estimation. 8 for x, then for y will be 141. And after that, we will connect the points using a straight line. So make sure that all points are intersected. So we will just extend our graph. Okay, and we now have this graphical presentation.